All right. In this lesson, we're going to take a look at compound angle formulas, which is basically a fancy way for how do we take a trig ratio, a sine, cos, or tan, of something that's two angles instead of just one. So pi over 2 plus pi over 4, or so on. Now, I do want to point out that we actually have kind of did this in our last lesson where we did the compound of, well, it was pi over 2 plus theta for some value of theta. But this is going to be for any two angles. So here we have two formulas, and unlike many times where I try to show you how the formula was derived, I'm not even going to try on this one. But we have two formulas here, one for the sine and one for the cos ratios of compound angles. And I'm just going to give you a second to look those over and kind of digest what's there. There's one thing that's important that I do want to point out, but I'm just going to give you a second. So take a look at those formulas and see if you see a pattern. Okay, so they're pretty straightforward. The cos one, the cos one I find a little bit easier because it's basically the coses of both angles multiplied together minus or plus the sine of the angles multiplied together. Whereas the sine one is sine of A cos B plus or minus cos of A sine of B. Now the important thing here is at the symbols plus and minus. So you've probably seen that before. Plus and minus just means that it could be add or subtract. The new one, though, is the one below it in the cos formula, which is minus plus, which almost everyone thinks means the same thing. And it kind of does if it's on its own. The fact that this is a plus minus here and a minus plus here means that whatever sign you put into the cos, you have to do the opposite sign between the first and second terms on the right-hand side. So for instance, if this side was a plus, then this side would have to be a minus. And similarly, if this side was a minus, this would have to be a plus. Now the top ones are the exact opposite. They actually just have to be exactly the same. So if it's a plus on the left, it's a plus on the right. If it's a minus on the left, it's a minus on the right. That's really the only trick to this, is the plus minus minus plus. Let's just jump in and try a couple of examples here. So let's evaluate sine of pi over 3 plus pi over 6. We're going to do it two ways. The first way we're going to do it is evaluate it by adding the angles first. So I'm just going to kind of at the side here, I guess at the top, pi over 3 plus pi over 6 equals, we got to find a common denominator of 6, which is 2 pi over 6 plus pi over 6 is 3 pi over 6, which is pi over 2. Okay, well that's not too bad then. Sine of pi over 3 plus pi over 6 equals sine of pi over 2. And pi over 2 is, again, just 90 degrees. Sine of 90 degrees is 1. So in this case, it was definitely, I think, fairly easy to just add the angles together and then figure out what the sine of that sum was. Now, if we want to use the formula above, I'm going to just bring it back onto the screen for a brief moment so we can see it. It would be the sine of pi over 3 plus pi over 6 equals, now we have to do sine of A cos of B, so sine pi over 3 cos pi over 6. And whatever the sign is here at the beginning has to be the same sign over here, so this will be a plus as well. And now it's going to be the cos of pi over 3 sine of pi over 6. Okay, so far not too hard, but relatively long. Now the good news is all of those are special angle formulas that we already know how to deal with. I'll be honest with you here. I keep a copy of the trig identities on a sheet beside me, as well as the exact identity formulas. Not because I can't figure them out, but because I hate having to take 5 or 10 seconds for each one of these to think about them. Bring back my pen. I've got to get better at switching back and forth between screens. Anyway, over here we've got sine of pi over 3. That's root 3 over 2. Cos of pi over 6. That's root 3 over 2 as well. Cos of pi over 3 is 1/2. And sine of pi over 6 also 1/2. So root 3 over 2 squared becomes 3 over 4, plus 1/2 squared is 1 over 4, which is 1. And hey, yep, these are equal. We've done something right. Now let's do this one again. Now this time it says use a calculator, and the reason for that is because pi over 5 and minus pi over 7 is not going to be a pretty number to work with. So let's try subtracting those angles. Pi over 5 minus pi over 7. Well, we need a common denominator of 35. So that'll be 7 pi on the top, 5 pi on the top, which gives us 2 pi over 35. Definitely not one of our special angles. Well, that's okay. Cos of pi over 5 minus pi over 7 is equal to cos of 2 pi. Oh, if I decide to quit on Tuesday. Yeah, that would be awesome. I'll have to read that later. If only that was an option. Okay, cos of 2 pi over 35. Now this is where we're going to pull out our calculators. And I'm going to remind you that 2 pi over 35 is in radians, so please make sure your calculator's in radians. I'm pretty sure most of you will know how to do that. There's probably a button on your calculator that says deg, rad, grad, or possibly DRG to let you switch back and forth. And at the top on your screen, it probably has either a DR or G, or the words deg, rad, or grad. You want to make sure your calculator's in rad, because this is a radian angle. Just as a side story, if you're wondering why there's a grad on your calculator, grad on the calculator is, grads in general are an attempt to make a metric version of degrees. So instead of doing a 90-degree right angle with 360 in a circle, grads has 100 grads in a right angle, 400 grads in a circle. And it's used by a little bit of engineering, but honestly nothing I've ever done. It seems to be kind of a weird, useless thing. Okay, so anyway, once we're in radians, we just punch in 2 times pi. If you have a pi button, use it. If not, use 3.14. Divide by 35, and then take the cos of that number. And you should get out 0.9839. And just a reminder, depending on your calculator, you may have to punch in the order slightly differently. I've got an older calculator, although some new calculators do it where you have to put in the angle first and then hit the cos button. And in a lot of new calculators, you put in cos and then punch in the angle. So you'll have to figure out how to do it, but either way, if you've done it correctly, you should get 0.9839. Now if we use the compound angle formula, we're doing the cos of 2 angles, subtracting them. So that means we want to use our difference of 2 things with the cos equation. And the formula for that says cos of the first angle, cos of the second angle. And then the formula says we have cos x plus or minus y, and then at the end we have minus or plus, so it means the opposite sign. We subtracted before, so now we're going to add. And then we just type in, or write in sine pi over 5, sine pi over 7. All right, I'm going to pause it for a second and calculate those numbers because it's a I'm going to pause it for a second and calculate those numbers just because I don't want to waste your time while I punch a whole bunch of stuff into my calculator. You can do that just as easily. If you want to try this on your own, by all means, pause. You've got 1 second to do so, and then I'll come back with the answers. Okay, and like magic, there we are. Okay, so after finishing that one off, I think we can look at it and compare the two numbers and say, yeah, it's the same regardless of which way we do it. The question is, which way would we rather do it? Now, in this particular case, I think we're using the calculator anyway. I think the left-hand side is much nicer. It's shorter anyway, but if we wanted to do it exact, then I think we'd be stuck with using the method that we used in part B. Speaking of finding exact, let's do that in question 3. So I'll tell you right now, the trick to this, it may seem kind of weird, is to find two things that add or subtract to 75 from our list of known special angles. So I'll tell you right now, there's actually many options here available. Some are smaller and easier to work with. Some are larger and not so easy to work with, but there's more than one. So I will erase this in just a moment, but I wanted to show you that you could use 30 degrees plus 45 degrees. What else could you use? You could use 120 minus 45 degrees. You could use, what else could we use? We could use 300 minus 225 degrees. Those are all angles that we have on our special angle ratio chart, our exact values chart from our special angles. I'm going to tell you right now, I usually like to do the smaller, easier ones when possible. So let's use those. Now for the 195, it may take you an extra moment to figure out which numbers work, but they are there. So I believe the smallest one that we can use is actually going to be, what would it be, 240 degrees minus 45. That works. Those are both special angles we know. Actually, we have 225 minus 30. That works as well. We could do the sum of two, I think. Now we do 120 plus 75. Oh wait, we don't have 75. We just figured out 75 on the other side, so that one doesn't work. We could do 135 plus 60. And there's more. There's quite a few that you can do. Again, normally I would pick the smallest ones, which I think are 135 plus 60, but just for some variety, I'm going to do a minus. So I'm going to do 200 and I'll do the 240 degrees minus 45. And I'm just going to erase those so that I've got a little more room to work now that we don't need that thought process there anymore. All right. So now to do the double angle, or sorry, the compound angle formula, I can say that sine 75 is the same thing as sine 30 plus 45. And I look at my chart and my equation formula table, and it says the sine of a plus b or x plus y, whichever variables you choose to use, is always going to be the sine of the first angle times the cos of the second angle plus the cos of the first angle times the sine of the second angle. And by the way, first and second angle here are completely irrelevant since 30 plus 45 equals 45 plus 35, as long as we're consistent in the use of our formula. Okay, and then we go to our sheet, or at least I go to my sheet. I would recommend you make a sheet. Sine of 30 degrees is going to be 1/2. Cos of 45 is 1 over root 2. Cos of 30 is root 3 over 2. And sine of 45 is 1 over root 2. So that's going to be 1 over 2 root 2 plus 3 over 2 root 2 root 3 over 2 root 2, which is 1 plus root 3 over 2 root 2. At this point, that's a perfectly valid answer. However, there's a little trick that I like to do called rationalizing the denominator, which is good form in mathematics, and that's to not leave a radical or a square root on the bottom if you don't have to, unless it's a really simple one, like 1 over root 2. But in this case, if I multiply top and bottom by root 2, I get root 2 plus root 2 times root 3 is root 6. And 2 times root 2 times root 2 is 2 times root 2 squared is 4. So both of those are valid answers. I would argue the second one is slightly better, but unless I ask you specifically to rationalize the denominator, I don't care. They're both beautiful. All right, let's try the second one then. Cos of 195 is the same thing as cos of 240 minus 45. And the formula for that one says that we take the cos of both of the angles, multiply them together, and then it's minus plus, which means it's the opposite side of the one we've already used. So we used a minus between the 240 and the 45, so now we use a plus, and now we do sine of 240 and sine of 45. Okay, when we plug that all in, cos of 240 degrees is negative a half. Cos of 45 is 1 over root 2. Sine of 240 is negative root 3 over 2. Sine of 45 is 1 over root 2. So that gives us negative 1 over 2 root 2 minus root 3 over 2 root 2. And if we factor out a negative there, it's going to be 1 plus root 3 over 2 root 2, which actually looks just like the one that we just did in part A, except for the negative sign in front. And we could rationalize it the same way. Okay, so that's all there is to using the sum and difference formulas for trig functions, for trig ratios, I should say. The last thing I want to do here is just look at double angle formulas. So I'm going to write out sine of 2a equals sine of a plus a. Go over to my identities sheet and see that that says sine a cos a plus cos a sine a. Normally it would be cos a sine b. Sine a cos b plus cos a sine b, but they're both a's now. And those are actually the exact same two terms, just in different orders. Sine a, cos a sine a. Either way, we get 2 sine a's times cos a. And that's my trig identity for double angle of sine. Sine 2a equals 2 sine a cos a. So now we can feel free to use that anytime we need a double angle identity. Similarly, cos 2a equals cos a plus a is cos a minus, because we have to have the opposite sign, we had a plus a, so now it's a minus, sine a sine a, which is just cos squared a minus sine squared a. And a reminder that cos squared a really means the same thing as cos of a, find that value and then square it. So we could put it in a bracket, put the square on the outside, but this is the preferred notation. And that gives us our double angle identity for cos. Cos squared a minus sine squared a. Now just before I put a box around that one, I'm going to remind you back to one of the other identities we learned, which was the sine squared a plus cos squared a equals 1, which was the Pythagorean identity. And we can actually use that if we'd like, along with this, to eliminate it, one of the two things, either the sine squared a or the cos squared a, and get different versions of this formula. So what I can do is say, get rid of sine squared a, and that'll give me 2 cos squared a minus 1. Or I can eliminate the cos squareds and get 1 minus 2 sine squared a. And I now have 3 different variations of the double identity formula for cos to use. Which one you use is really dependent on how you need to use them when you're, or how you need to approach a problem when you're trying to prove a trig identity. If you see something that only has cos squared identities, maybe use the middle one. If you see one that only has sine squared, maybe try the bottom one. But really, it depends on the situation. There is no right or no wrong. So I'm going to stop there. And basically, there are some homework questions there for you to try. This stuff is pretty straightforward. It's really just a formula and plug and play. Again, I have my identity sheet in front of me along with all my special exact values because I hate having to remember all that stuff, and so I don't. You're welcome to do the same. I'm going to post something, but you can always make your own version to your own short cheat sheet if you'd like to use it, and then you're good to go. So if you have any questions about this stuff, let me know and we'll take it up. Otherwise, I will see you in the next lesson. Have a great day. Bye.